Another session. In this session, we are going to discuss about designing of integrator, or also called as low-pass filter, using op-amp in the Multisim software. Before going into the Multisim software designing, first we should understand the theoretical calculation of the integrator, how an op-amp can be designed with the help of operational amplifier. How can be it is designed as integration, and how we are going to evaluated, or how we are going to perform the operation of integration with help of op-amp, and also why it is called as low pass filter. If you think that if you observe the response, it means the output response of integrator is exactly looking like an low pass filter. This is also we are going to see in this session. So first see about the theoretical calculation. Now let's see observe that here we can consider that this is an integrator with a inverting configuration. You can clearly observe that the input has been given to the inverting configuration, so it is called inverting integration. So it means that if you have been taken the input as a sine wave, suppose, just consider that. So if you could have been taken as input as a sine wave, but actually the output, so I am assuming that my input is sine wave. Okay, so what is the integration of sine wave? On integrating, if we integrate this one, what we will get? Integration of sine t is minus cos t, right? So minus cos t, in the sense we will get output waveform in this manner. But what we will get, the output of this is a cos wave which is having normal waveform. Why? Because that we are going to see right now itself. Okay, don't over think about this, how waveforms has been coming. Now I am going to explain. So let us consider that Kirchhoff current law, sum of entering currents is equals to sum of leaving currents. So here the sum of entering currents, this is the leaving current, as we are discussed in the past two sessions about the current law in the inverting and non-inverting configuration. So you are very familiar about that. So if you are not familiar, please go and watch that videos that will be given in the description box. Okay. So let us consider that this current I am taking as I1, and this current I am taking I2. So applying the Kirchhoff current law, so V naught minus 0 by R, which is equals to 0 minus, so we are familiar with Q is equals to CV, right? So on differentiation, what we will get here, dq by dt, that is I, which is equals to C into dV by dt. So in the capacitor, the current equation is C into dV by dt. So 0 minus C into dV naught by dt. This is the expression. Okay. So on simplifying, we will get V by R is equals to minus C into dV naught by dt. So we want the output, correct, right? So V naught is equals to, on shifting this C in this side, then we will going to get minus V by RC. This differentiation, when we transferring from differentiation into other type, then it will be changing to integration form. So you can clearly observe that V naught is equals to minus 1 by RC into integral of VDT. It means if we are transferring a sinusoidal signal as a input to the one end of the one end, then we will be going to get an output such that it is an output such that we will be having an input like this way, but sinusoidal. On performing integration with the help of op amp, is an integration, we will be going to get integration of sine, actually integral of sine t will be minus cos t, correct, right? But because of having already we are using inverting configuration, right? So with the by the advantage of inverting configuration, we are not going to get the inverting output minus cos t, but we will get the positive because minus of minus will get plus. So in this way we will going to get the output. So now let's execute in the multisim software, analyzing this one. Okay, so let's go to the multisim software. Here you can observe that, so I have already been designed. So now here you can see this is the function generator. How you will get, you can see in the bottom corner, in the left rightmost corner, you will see multimeter, function generator, watt meter, and oscilloscope, 4 channel oscilloscope, board plotter, which is used for the responses like low pass filter, high pass filter. That also we are going to see here itself. And this is the frequency counter, word generator, logical converter. These are all the so many things are there too. For the different purpose we are using different one. So for our use to give the different inputs, I'm considering a function generator which will be available in the second, I think so. So second most one you can get it there, and in this one you will get a sine wave as well as triangular wave as well as the pulse wave, whichever you want you can give directly. So you can consider that this is a op-amp 741 IC which is having a 5 terminals, saturation voltages has been given, and the resistor and capacitor which is connected in series when we consider in idle mode, which is in inverting configuration, and this function generator is used to show the output waveform. So now, so I have been considered this sine wave with a 10 kilohertz frequency which having 5 amplitude peak to peak. So let's run this one. So when I run this one, it is simulating and to get the input and output waveform. So it is blinking, right? So let's stop this one and observe whether it is we are getting the right output or not. So to clearly observe that, so initially it is because of some noise or some other external source offsets are, so it is not going to get. To compare this one, so now I am considering from here itself. So you can observe that this is the sine wave starting from here. What is the integration of sine t? Which is minus cos t, right? But the output waveform starts from here. But because of having inverting configuration, we will get the positive output. So cos t. Okay, sin t minus cos t, but we are using inverting configuration, so we will get positive output. In this way integration operation is performed with help of the op-amp using multisim software. In this way we are going to design a integrated circuit with the help of multisim circuit. Okay, this is how for the integration design. Now we will see low pass filter. You can also observe here that when I change the input, when I give the pulse input, then the output is going to be triangular wave. So output integration of the pulse is triangular wave. Hmm? Hmm. You can clearly. In the first part, we see the how the operational amplifier is behaving as an integrator. Now we'll see this same integrator how it can behave like a low pass filter. Now let us observe same thing, but instead of oscilloscope we are putting as board plotter. Here it will be available here in the rightmost corner and the position of fifth. So you can clearly that, and you should connect any of the input to that board plotter input, and also you can connect the output to measure the frequency response is nothing but low pass filter, whether it will allow the low frequencies or high frequencies, that will be same. So let's run this program, you will better understand. Okay, so when we run the program, then you can clearly observe that it is so I'm shifting this one. So you can clearly observe that as we are all familiar, the low pass filter response should be like this way only, right? So initially it's like wait for that one minute, I'm going to explain this one. So the low pass filter response should be like this one, right? Wait, I'm checking. Okay, you can see here the low pass filter response should be, first it will allow the all the low pass signals to take, this is as a frequency axis and this is a gain axis. Then First, it will allow all the low frequency signal up to certain frequency according to the cutoff frequency. Then it will reject all the remaining filters. So, in a similar manner, you can also clearly observe in this diagram, right? So, it will be allowing in the topmost. We are not able to see that one, right? So, it will accept all the low frequency signal. Then it will reject all remaining signals. So in this way, the integrator is behaving like an low pass filter. In upcoming session, we are going to discuss about that high pass filter along with how it behaves like an differentiator. So this is how for this session. If you have any doubts, please comment us below. And if you are not watched the previous sessions, you go on must and should watch that videos. Then only you will understand all the concepts of op amp using multisim. So I will provide all the links in description box. You go and check that one. And if you are not subscribed till now our channel, please subscribe our channel and help us to grow in this field. And if you have any suggestions to improve our channel, please let me in comment box. Thank you for watching.